Hello everyone, this is Sam Spade with another tutorial in the Buttons Design in GameMaker Studio 2.3 series. In this tutorial, we're going to be talking about using the keyboard to interact with all of the buttons that we've created. And we're actually going to write the code for 2.3 and 2.25 in the same tutorial because there's almost no difference. I'm going to split this up into two parts. In the first part, we'll be creating the keyboard graph, which I'll talk about in a moment, and the means of traversing that graph. And in the second part, we'll be connecting that graph with the actual buttons. This is also a great place to talk about different designs. I've come up with this one. I think it works pretty well, but there are really a lot of different ways you could have done it. And I'd certainly be interested in hearing about your methods down below in the comments. And that ranges from everything to how you would implement the graph, especially in 2.3. Would you have decided to use structs instead of maps? Or maybe you would have come up with a different system entirely. Because there isn't just one way to do it. We have our collection of buttons down here, and then we created a mouse manager, which there's only one, and it interacts with all the buttons, and the buttons interact with it. And now we're going to create a separate keyboard manager. But is this really the right way? Or maybe there's a different way. Maybe you'd want to integrate the keyboard and the mouse manager. Maybe you'd somehow want to just do it as a global variable that gets updated. But I think that this, again, is a pretty straightforward way, easy to implement, easy to understand, and so it's what we're going to do. So our keyboard manager is essentially going to be a graph, and it's going to be built on top of the DS map, the built-in GameMaker data structure, the map. If you watched the graph data structure tutorial in the Coding Fundamentals series, you'll be familiar with it, but this will be a little bit different and actually a little bit simpler and more straightforward. We're really only going to have two functions, and that's going to be add node and add edges. And we're going to have a third function that will allow us to traverse the graph with the keyboard. This is a simple diagram of our graph. We're going to have the graph itself. This will be a DS map. Inside of the graph, we're going to have nodes like this, and each node is also going to be a DS map. And inside of each node, it's going to track what other nodes it's connected to with these connections. And we'll use that with the traverse function to look up which nodes are connected to which nodes. And if you push left, for example, is there a left connection, and so on. This will make more sense, I think, when we actually get into the code. So let's jump over right now. All right, let's start by creating our keyboard manager, which I've actually decided to call our button graph, since that's ultimately what it's going to be. So I'm going to make a new folder, call it button graph, and I'm going to have a button graph parent. And in the button graph parent, we're going to need a couple things. First, we're going to have a create event, call it button graph. Parent will have a cleanup event, and you'll see why in a moment. Button graph parent, and then we're also going to have step event. Button graph parent. As we discussed with the slides, our graph is going to be made up of a map of maps. So we want to initialize our initial map. We're going to call it button graph equals DS map create. Now, if you've watched the custom data structure, you may notice that here I'm doing it directly inside of the object, whereas there I created a script that would do it. This is an interesting design point I think that's worth thinking about briefly. The reason I'm doing it inside of an object here is because the only time this button graph is ever going to exist is when an instance of this object exists. I'm not going to use a bunch of scripts to create a graph inside of any type of object. It's not some generic graph. It's a very specific graph for a very specific purpose. And since I know it is only going to exist in this object, I don't really need to create a wrapper script for it. But if I were going to create a more generalized graph structure, I'd probably have this inside of a wrapper script for the reasons discussed in that other tutorial. Next, we need to clean this up. So ds map destroy button graph. And then in the step event, we want to be able to traverse our graph. And so we're simply going to say if keyboard check pressed VK up. And now we know that we're going to want this for each of the other four directions as well. VK down, left, and right. And we'll come back and put the script in here that we want to run when we push up, down, left, or right after we've written it. So here we go. This is our basic button graph parent. It creates the button graph, which will get destroyed when it gets cleaned up. And we'll have a step event, which we'll add stuff to in just a moment. But now we want to create some scripts. Let's move all of our mouse manager scripts into their own folder. Then we can create a new folder for the button graph. And now we're going to need 3 different scripts. We're going to need to be able to add a node, add an edge, and traverse the graph. Let's create our add node first. So this will be button graph, add node, button graph, add node. That's going to be the button name. Actually, let's just call it button name. And it will be add a node to the graph. So this is a really easy one. We're always going to call it from inside of the button graph so we can rely on its variables. And it's just ds map, add map, button graph. That's the map we want to add our new node to. Argument 0. And then ds map create. So let's walk through this for one moment. We are adding a node to our graph. But remember that our node is also a map. So we are saying button graph, that's the map that we want to add our node to. We're going to make the key for that node the name of the button. And then we're creating a new map and sticking it inside of the button graph. And because we are sticking a map inside of a map, we are using the function dsMapAddMap. Now, this is technically unnecessary here. It would work without it because we're always going to pull the map out, as you will see. But if we do dsMapAddMap, it means that in the debugger, it will automatically recognize internal maps. And more importantly, when we destroy the main map, all submaps get destroyed as well. So even though we're going to have a map of maps, that means we're going to have one ds map for our graph and then one ds map for each button in our graph. So that could be 5, 6, who knows how many. We only have to call the ds map destroy once, because since every map is added to this map as a map, GameMaker knows when you destroy the main map, destroy all of its submaps. So before we create any more scripts, let's actually create our graph and add some buttons to it. To do that, we're going to create a specific object of button graph parent. We'll call it object button graph. It needs to be a child of button graph parent. And we are going to inherit the create event. Let's rename this button graphs, button graph. So it's inheriting the create event, which means it's getting its map created. And now we want to add some specific buttons to it. And now before we run it, let's come over here to the room, stick in our button graph, and see if it's working. Okay, I've run it in the debugger, and now we can see object button graph exists down here. Let's tell GameMaker to view it as a DS map. And because we added them as maps, GameMaker already knows that all of these are maps as well. And you can see the 3 nodes we added: credit, start, secret, and options. Note that they're not in the order that we added, and that won't matter. And then they're all empty right now. So here we go. We have our main graph, our main map, and then all of our submaps, which we will start populating right now. So let's come over here and create the next script. Create script, button graph, add edge. It's going to need the name of button A, the direction, the name of button B, and whether or not that direction should be 2-way. We want to add this information in down here. Add an edge to the graph. We're also going to rename our arguments for ease of use. And now we're almost ready to write the heart of the script, but because GameMaker 2.25 doesn't allow us to have chained accessors, we actually have to pull the node out of the main map first so that we can reference it. So we'll want 2 more variables, button A node and button B node. And then we just want to get these nodes from our main map. So we're going into our button graph. We're using the name of the button, which is the key to the map. We're pulling that map out and we're saving it to its own variable so that we can now reference that variable directly. So now we need to add the main edge. And what I mean by that is we need to add the direction from A to B. So that's pretty simple. We just want to say button A node. Now that we can access this map directly, we want to take our direction and say that that direction equals button B. So what does this line of code do? Well, it takes our node, which is a map. So we're using a map accessor, and we're saying set direction to button B. This means that it will look direction up in a map, which is a key, remember, because we're passing it in as a string. And if it doesn't exist, it will write button B into that direction. And if it already did exist, button B would overwrite what's going in. And now we want to say if this direction is supposed to go two ways, we're just going to hard code this because I think it's pretty easy to understand. Does mean a lot of typing though. Okay, let's review this for a moment. So what does this do? First of all, it will only run if we want the connection to go both ways. If we want the connection to go only one way, all we need is this first line here. However, if we want the direction to go two ways, we actually need to reverse the direction, and the easiest way to do that is to just hard code it because we only have 4 directions. So we're going to use a switch statement where we take the current direction and then we will simply repeat this line right here, but reversed. So we're going to save button A in button B with the reverse of whatever the direction is. So if left was passed in, we'll save button A's name to right. If right is passed in, we'll save it to left, up, down, and then down, up. So let's switch back to our button graph and add in some edges. Button graph, add edge. We want to go start. We want that to go down. We want it to go to options. And we do want it to be two ways. Let me just duplicate this. Then we want options to go to credits and credits to go to start. And we want all of this to be two ways, except for this last one. And then finally, let's do one more thing here. Let's have credits go left to secret. And we do want this to be two ways or we'll get stuck over there. So now what we should have is we should have the ability to go from start to options to credit, and credits will loop around to start, but start won't loop back to credits. Now we can't actually traverse our graph yet, but we should be able to actually see all of this data represented when we run our program. So we come over here, view this as a map. So credits goes up to options, left to secret, and down to start. Start just goes down to options. Options goes up to start and down to credits, and secret just goes right to credits. Hopefully I spelled all of these correctly. If not, you'll see a message on your screen letting you know. All right, it's time to write the last script, and this script will be pretty straightforward. Let's create a script, call it button graph traverse. Move it over to our scripts, and also let's just call this scripts button graph traverse. It will take a single argument, and that will be the direction. Direction will be a string. And we will traverse the graph. Let's just rename our argument direction. So now we need to get the node that we're currently on in the graph. We actually haven't set that up yet, but let's just pretend we have. And this is often a really useful strategy while coding, right? We want to know where we're currently at. It would be nice if we could just type button graph position, where position is the key, the point of the graph that we are currently on. So let's just pretend we have this variable and it exists. Now we can say if node direction does not equal undefined. So remember that our node is a map. We're going to look up that direction in the map. If it doesn't exist, it will be undefined. If it does exist, it will return the data, which is the name of the node that it points to. And then we can just say position now equals this new node. And that's all we actually need. But just so we can see it working, since we haven't actually connected this to our buttons, we will print out the value of position. Now, obviously, we need to create this variable. I'm going to do it as a object variable, position, string, default. And now we can come over to our room, come up here, variables, name this start. An important point is that if you don't have these matched up exactly, because we haven't put in any error checking in our scripts, we would get a game crashing error. That's fine for what we're doing here, but if you were doing this on your own, you might actually want to have additional checks to make sure that what you're looking for is actually valid in the first place. The final thing to do now is come over to our step event and just add this in. Button graph traverse up, copy it, and this should be down, left, and right. Okay, we should be able to run this now and see it working. Okay, so we have it, and I've tested it out a little bit, but we can hit down, credits, start, options, credits, start, options, exactly what you would expect. Options can go to start, start can't go anywhere. And then from credits, we can go over to secret and back to credits, and everything is connected and we can traverse the graph. So that's it for 2.25. We're going to jump over to 2.3 now, where we'll actually get to update this code in a couple cool ways that'll make it a little bit easier to use. And then we'll be back in the next tutorial to actually hook this up with all of our buttons. Okay, now let's do this in 2.3. The code is actually so similar that I don't think it would be all that interesting for me to retype it all. So I've already implemented it, and I'm simply going to go over the changes. The first thing to know is that we actually have fewer things we need to do. Because we can use methods, we only need button graph parent and object button graph. And then all of the scripts that we wrote can simply be methods inside of button graph parent. Not only that, but because they can be methods, we can simplify their names since we don't really have to worry about them conflicting with anything else. So button graph add node, button graph add edge, and button graph traverse just become add node, add edge, and traverse. With the exception of adding the methods, which we'll go over in a moment, to the create event. The create event is otherwise the same. We have button graph equals dsmap create. Our cleanup event destroys the button graph. Our step event just has the keyboard checks up, down, left, and right. And we've renamed the function to just traverse. And then the create event of our button graph object is actually identical, except for the fact that we simply renamed all of the functions. And then of course in our button graph parent, we still have our position variable down here, which we're setting to default to start with. So the only thing that actually changes really at all are these functions. And the functions don't even change all that much. For add node, the only thing that's really changed is we get to name our arguments. So we can simply use node name and put that in here. If we come over here to 2.25, we can see it's just the same line, except we used argument 0. So that's all we need to change for add node, and we don't actually even need to change it. We could have just used argument 0 and argument 0. Add edge gets a few changes. First, again, we can name arguments, so we can put all of our argument names in the top. But then, and this is one of the cool quality of life features in 2.3, we can now chain accessors. So we can say button graph, button A, direction equals B. Notice that we're no longer pulling the node out of the button graph. So if we switch over to 2.25, we have to come over here to button graph, and we have to actually get that embedded map or that sub map and save it to a variable so that we can then access it, because there's no way to chain accessors in 2.25. But in 2.3, we can do that. We can simply say, get the direction of this node. And we can make that same change down here so that we don't have to pull out either of the sub nodes. And then finally, we have the traverse function. This function is also pretty much the same as the 2.25 function, except again, we get to rename our arguments, or directly name our arguments, I should say, and we can chain the accessors so that we don't have to pull it out and then check. Again, coming over here to look at 2.25, we have to rename our argument, pull out the node, and then we can do that same code. So in 2.3, everything is basically the exact same code-wise, but the quality of life features actually make our code a lot more compact and easy to use, which I personally think is pretty great. Let's demonstrate that this still works by running it once. So here we go, and then we have our output down there. While I didn't show it, I did add object button graph to the room. We can go down to options, down to credits, down to start, and it will loop. If we want to go up, it does not loop. And then from credits, we can go left to secret and back to credits. So there you go, everything works. And that's it for all of the code in both 2.25 and 2.3. All right, that's it for the moment. We'll be back in part 2 to talk about how to implement this with our actual buttons so that we can actually interact with the buttons rather than just traversing the graph, so that our buttons reflect what our graph is doing. And that's it. Thanks for watching.